The broadcast is now starting. All attendees are in listen-only mode.
All right. Hello, everyone, and welcome to this webinar. My name is Victor Sanchez, and I'm a product specialist from Next Limit for both RealFlow and Maxwell Render. Here, just right by my side, is Luis Miguel Mora.
Hi, everyone. I am RealFlow specialist too.
All right, and Maxwell as well. All right. First of all, thank you very much for your time, for being there. It's extremely important for us to have a good time with you, making a very quick walk through the main features of RealFlow. And hopefully you'll get the idea about what can you achieve with this tool. I have to apologize for, especially for those of you who've tried to join our webinar early this morning, as some attendees unfortunately couldn't make it just because we were literally full, crowded, and only were able to manage about 100 attendees. But hopefully right now we don't have that issue as well. So apologize if you tried to join us early in the morning, and I hope that this time you will enjoy the show. Additionally, I would like to reinforce the ability or the possibility of sending us any question related to this webinar or RealFlow in general. Luis and me will try to manage as possible on the fly. We will collect some of the questions that the attendees made earlier in the morning. And of course, we will try once again to answer on the fly your questions and your comments. And at the end of the day, we will collect them all and send you forward with the answers. And if there's any question that we can answer in this session right now, don't worry at all. We will collect them all and forward you properly answered. Okay? So, first of all, this is RealFlow 101. It's a quick walkthrough the tool, especially for those of you who are not familiar with RealFlow. And in this case, we will take a look at some of the new features, latest technology and solvers that we recently introduced in RealFlow in order to generate and deal with particles, fluids, and liquids and stuff. So let me show you a couple of things here before start. RealFlow is a very, very standard tool. It's a standalone application, and it's pretty standard, perfectly integrated with most of the 3D platforms, more of the most popular 3D packages such as 3ds Max, Maya, Houdini, Lightwave, etc. We have connectivity plugins for all of them, and it's been out for almost 20 years. I mean, at the end of the 90s, we actually had the very first versions of RealFlow, and it's become actually a standard in the industry. So if you're considering a fluid or liquids project, definitely RealFlow can help you out with the project. RealFlow is about dealing with fluids, with particles, with emitters on one hand. On the other hand, we have to deal with forces and geometry. Okay, so RealFlow as a standalone application will talk to your 3D platform. Basically, the workflow we will see it in a minute is about bring geometry into RealFlow, simulate, generate the fluids, meshes, particles, whatever, apply the forces and set up the colliding geometry that we will use in our project. And finally, we can either go two ways. We can either render it out directly from RealFlow or export, bring it back to the 3D platform, to the 3D package, and then render it out with your render engine. Okay, so it's pretty much workflow like this one. Is a back and forth two-way communication workflow actually from your 3D package to the RealFlow standalone application. And we will see an example immediately. Just to wrap up this boring part presentation, let me call you about this Spanish Winter promo. We are currently running a very, very good deal for those of you who are interested in acquiring RealFlow, but time is running out and we'll end up on December 15. So just take a look at the details on our website and just bear in mind this is available only via resellers. So definitely worth to take a look at it. All right. So first of all, I'm going to close this thing here. And as I mentioned before, the workflow starts over in our 3D platform. Okay, so here we have a very simple scene, nothing too fancy actually, just a glass geometry. And if we take a quick preview, this is what we have here, is glass with an HDR map in Maya. I'm going to perform this webinar with Maya, but once again, it doesn't matter if you are a 3ds Max user or Lightwave user or Houdini, Cinema 4D, whatever. We have connectivity plugins for all of these platforms. Okay, so first of all, I'm going to export this geometry, and because this is the geometry I'm going to use for interacting with RealFlow, I'm going to create a new folder here. Yes, because I actually did it before, and I'm going to export the geometry. The export process is basically to generate an SD file, a scene data file. It's our proprietary format for dealing with geometry, but you can either use other formats such as Alembic or even OBJs. You can directly import OBJs in RealFlow. So if we take a look at the folder, here you will see that we have our little file, our little glass here. And what I'm going to do is launch RealFlow. By the way, you will see that I'm using the 186 version, which is not public yet. We will release a minor upgrade next week, probably Tuesday or Wednesday, and we'll introduce a few improvements and enhancements that we will mention later. And here I'm going to create a new project. Okay, I'm going to name it as glass under my default scenes folder, and RealFlow is going to generate the project folder here and the FLW file containing the RealFlow project specs. Okay, I'm going to click on create, and if I open up the folder, I can see here the glass, the geometry glass, the FLW file, which is the RealFlow document, putting it bluntly. And here you will see a few different bunch of folders. And all right, what I'm going to do is import this geometry here just by clicking on geometry, import, locate the path, and bring it here to RealFlow. Okay, so this is the geometry. If I click 5, this is the camera setup directly from Maya when I export it. I'm going to press 4 to go back to the perspective view, and I'm going to get rid actually of the camera. Okay, if you take a look at the grid here, you will see that the glass is huge. It's really huge. This is because actually I'm currently working here in centimeters in Maya. So each one of these little square is 1 centimeter. And here in RealFlow, each one of these squares is equal 1 meter. So if I just want to match the scale, I can set up to 0.01, and this is pretty much the real scale or the real matching between RealFlow and Maya. It doesn't mean that I have to work exactly in real scale. This is really important. In this case, if you take a look at this, this is roughly about 8 or 9 centimeters, which is pretty much like in this case, assuming this is 1 meter. But once again, working with this scale is really hard because it makes RealFlow to perform a lot of computation in such tiny space, and it might affect RealFlow and become unstable, even crash. So I don't recommend you to deal exactly with the same scale. Of course, it's really important. The scale is going to determine if you are filling a swimming pool or a glass, actually. So it's going to be really crucial in the look of the fluid, of course. But with some expertise, you will notice that it's not strictly necessary work on a real scale. In this case, I'm going to scale it up a little bit. Okay, so I'm just going to use 0.15. And here you will see that we have the relationship editor. The relationship editor is pretty much this scenario, and these are the actors of the scene. Okay, I'm going to click on this panel here, these diverse emitters, and I'm going to click on a circle. Okay, so this is going to be my emitter. I'm going to generate particles just right from this guy, and probably decrease a little bit the scale of the circle. So you will see that here I have a domain, which is the subset where the simulation is going to happen, and the geometry, of course, and I have a hub. It is pretty much like the place where everything is going to be connected. And the hub, this general hub is enabled by default. Personally, I prefer to get rid of the hub and link the objects by myself, because for me, it doesn't make sense to make RealFlow inefficient and perform computations of everything reacting with everything. I'm going to specifically determine that I want to this guy, the geometry in this case, collide to the domain, or if I add additional forces or whatever, I'm going to set up the connections in between these elements, but I'm going to be very specific. So I will get rid of unnecessary connections, unnecessary computation, and consequently my workflow will be much more efficient. All right, my partner Mariana from the Foundry, let me close up Skype. All right, and here we have, I'm going to get rid of the grid. Here we have the emitter and the geometry. They're not linked at this moment. I link but then remove it. So if I just click on simulate, we will generate particles, but the particles are going to pass through the geometry. I have to tell RealFlow that I want these particles to collide with this guy here. So I'm just going to click on the node with control and add a noodle to the domain. If I click on reset and simulate, or the shortcut A in the keyboard, you will see that now the particles are going to react, are going to collide with the geometry here, okay? So this is the way that we have to tell RealFlow what are the actors, or which are the actors in the scene, and what's the way we want to interact in between themselves. All right, I'm going to reset, and next I'm going to add a force like gravity, for instance, and of course I have to link the gravity to the domain. So I have some gravity, and you will see here that some particles are colliding here, and some particles are trespassing the geometry here. This is because RealFlow needs to increase the substeps, the steps in between frames, in order to perform a much more accurate computation. We have some different ways to sort out this situation. One is go to the options, and in the Diverso tab here, because we're using Diverso technology, Diverso solver, which is the Diverso PVD in this case, enabled by default, we can crank up the min and max substeps here. So if I just click on reset and click on simulate, you will see that the particles are perfectly colliding with the geometry. All right. Luis says yes. All right, that's good. In this case, if you take a look at the domain here, in the domain tab, you will see, I'm going to forget about damp particles because they are not suitable for our fluid behavior. I'm just going to get strictly focused in liquid SPH and liquid PVD. Liquid PVD is a way to get fast previews or fast performance of particles. There, if you want to mimic real behavior of the fluids, it's probably way better to use the SPH solver. Again, if you can reset and simulate, now this SPH is going to take just a little bit more time for computation. I'm going to set the geometry as a bounding box here. And as mentioned before, it's going to take a little bit more time to compute, to calculate, but the result is going to be way better. Of course, we can see this weird layer, or this weird behavior here of the emitter, and we can play around with a little bit of randomness in vertical and horizontal planes of the emitter. So if I just click on A to resimulate, you will see that I just get rid of those weird behavior, right? RealFlow is all about sculpting fluids. It's pretty much about, say, I want this fluid to have much more friction, or to bounce more or less, or to have much more viscosity or density or whatever. So here under the emitter tab, I can control the speed, and I can control this randomness for the emitter here. And in the domain, I can control if I want to add much more particles, for instance. It's not necessary to crank up this to a crazy value, but the more particles, obviously, the more resolution, and consequently, the more convincing will be the simulation. Again, it's not strictly necessary to raise up this to a crazy value, because obviously you will end up with much more computation time, and sometimes a certain amount of particles is pretty much fine. Same thing for the geometry. For instance, if I select the geometry, the glass in this case, here I can tell RealFlow if I want this fluid to bounce more or less, actually, depending on the factor here. If I want to perform some friction and some roughness, if I want the fluid to have this kind of sticky behavior, so it's going to collide perfectly side by side with the with the walls of the geometry, it's about try and error all the time, going back and forth and moving just one single value at a time, and see pretty much what is happening here. Personally, I love to work with curves. Personally, I highly recommend you to work with curves in order to give the emitter a much more accurate look and feel. For instance, in this case, if I just click on the speed of the emitter, I can use a function, for instance, in order to play with these values here instead of a constant value. I can even draw literally as a spline the curve just right here. But in this case, I'm going to perform a very quick formula. Okay, and I'm going to play around just with the 3 different factors for this simulation. I'm going to use this this sine function in order to deal with this very nice structure, very nice natural curve here. And I'm going to use a factor here for the frequency, for instance. If I want to crank up the frequency, probably that's too much. All right, but let's say 20 times, for instance. Okay, you'll see that here the frequency is way much more frequent actually, rather than if I set up this guy to 3. Same thing with the amplitude. You can use this factor here, or you can decrease it with a value lower than 1. And here, this factor is pretty much the offset. For instance, if no offset at all, you will see that this is the value of the speed. The speed is going to be roughly about between minus 0.5 and 0.5. But if I just crank up this value here to 3, here we are about 2.5 and 375, something like that. All right, I can live with that. I'm going to select this value here and going to resimulate again just by clicking A. So you see here, this is the sine function acting to drive the speed of the emitter, the speed of the particles just right here, okay? And this is a much more natural look. I'm going to stop the simulation just roughly in about 20 seconds. We simulated much more than 100 frames. So if I scrub along the timeline, you will see here that this pouring is going to be way faster and definitely much more natural. It's going to have a much more natural behavior rather than a constant emission or something like that. RealFlow is all about that. It's about, mimic the fluids exactly the same way as you will do in the real life. You will see here that we have certain particles flying away, and it's pointless to have these particles being performed and forcing RealFlow to execute computation if they're going to fly away or something like that. So what we can do is to add a killer volume to literally kill these particles, literally kill the particles going out from a certain subset. Okay, so I'm going to add here this killer volume here, linked to the domain, of course, and fit the killer volume to the scene in this case. Okay, so here we have the glass and the killer volume. If I just click on reset and A for action, as in action, we will be simulating the particles, and those particles flying away here and going out the boundaries of the killer volume will literally be killed, will literally disappear. Okay, so this is once again a much more efficient workflow to deal only with the particles that you want to simulate. You will be dealing with killer volumes all the time. In this case, we're killing particles going out the boundaries of a volume, but you can either choose if you want to kill particles at a certain age. For instance, those particles with more than 2 seconds, 3 seconds, a certain number of frames, or if you want to kill particles depending on the velocity, for instance, of the particles, or if you want to kill particles depending on other different filters, other different things, you will be able to deal with that. Okay, so I'm going to stop this simulation right now. In about 1 minute, we have almost 200 frames in a 5-year-old machine. Nothing too fancy, just for cores, multi-threaded. And here is the proof of the power of this solver. It's really fast. If you definitely want to deal with small to medium scale simulations, definitely Diverso, these solvers around here, is the best option. You will notice other technology like Hybrido or the standard particles. Hybrido, Luis will talk us about Hybrido in a couple of minutes. And we also have these standard particles just right here. My personal recommendation is forget about the standard particles. We just keep them for compatibility purposes. They are based on the old classic solvers. They're not multi-threaded and they're not well optimized for the current machines, for the current hardware. So definitely we just it's a legacy technology actually, and will probably disappear in an upcoming version. Just get strictly focused in Diverso for small to mid-scale, and Hybrido to simulate large-scale simulation, massive amounts of water, such as oceans, flooding areas, tsunamis, things like that. Okay, and that's pretty much the idea to distinguish between the three different technologies. Okay, so now that we have our simulation, we can perform some different actions. We can generate an OpenGL preview, for instance. So we will be able to look how the look of this simulation is going to be. In this case, if I just click on escape here, I'm going to skip the whole thing. You'll see here that we can, okay, pretty much fine. If we click here and set as loop, that's pretty nice. I mean, it's just in a couple of clicks, we have this really nice simulation. And I'm going to close it. And now that we have the particles, is the time to perform machining around these particles. Actually, we're going to to create the geometry that we will be able to bring back to Maya, Max, Cinema 4D, Houdini, Lightwave, whatever. Okay, so in this case, we have 3 different types of meshes here. Again, this is the legacy way to generate meshes that we keep for compatibility purposes. Just you can safely ignore it at all and get strictly focused in these 2 guys here. This is a standard mesh with certain controls to define, to set up the look of the mesh. Or even better, you can use the recently brand new introduced particle mesh based on OpenVDB algorithm. This is pretty cool. These meshes are super fast, are very efficient in time, and automatically with one single click, you will see here that beneath that, under the name of the mesh, there is the emitter here. If we have some different emitters, we will be able to select which emitters we want to mesh around. In this, just by right click and select the particle source. In this case, we just have one single emitter, so automatically RealFlow is going to embed the emitter for me. And if I just right click and build, boom, immediately I have a feedback about how the mesh is looking at. If I keep the mesh selected, you will see here the number of faces. Obviously, the higher is the number of faces of triangles, the better the resolution. Sorry. Let let me perform a couple of actions here. First of all, in order to take a better look of the mesh, I'm going to hide the particles themselves and going to set up the mesh as a smooth shaded object here, okay? So you can see this kind of blobby aspect here, which is not pretty realistic, right? We probably should try to smooth the surface of this mesh, and there are some different ways to achieve that look, that shape. First of all, in the mesh tab, we can add a mesh filter, a general filter, and adding a few steps in order to achieve certain relaxation factor. This is the factor, and this is the steps to achieve such factor. So if I just click on build again, here you see that the mesh is much more smooth actually. In addition to that, I can perform, or I can add additional filters just by clicking here, and you'll see here that I have certain ways to delete or erode or even smooth much more the mesh itself. I'm going to add 3 loops or 3 iterations for getting a more smooth look, and you see here that this is a different story. This is a much more smooth surface that we can kind of build all along the timeline. Let me introduce a couple of words about Export Central. Export Central is pretty much where we are going to set up the cache of the simulation, where it's going to be stored. If we want to store it remotely or locally or whatever, we will be able to perform it. And also the way of setup if we want to export it as a Lembic file, for instance, or as a RealFlow proprietary binary format here. So I just click as a binary, and let's assume that I'm pretty much done with this look of the fluid. Okay, I'm going to set up the glass as a bounding box actually, and here I just click on the mesh and automatically tell RealFlow to build up the whole timeline of meshes for me. So you see here that RealFlow is frame by frame adding the meshes. I will be able to come here to Maya and tell via plugin to import the binary meshes here. Okay, so here in my folder, I have the meshes folder here. I just click on the mesh, create, and automatically you will see here that the mesh is bring back to Maya. RealFlow is meshing 80, 81, 82. So in Maya, I will be able to scrap out this timeline. Sorry, all right. This timeline here, and this is pretty much the mesh that we have. Okay. Last but not least, I can play around a little bit with Maxwell and tell, okay, this is going to be a glass material for the glass, a high-grade glass, for instance. Okay, so if I just click on fire, and Maya is going to export the scene, and I will be able to see this glass material to the glass actually. And let me stop this guy here, close fire, and apply pretty much the same process for the fluid, adding a new Maxwell material, and use the Nuclear Wizard to create a water material. Okay, so now these are already pretty much set. If I click on fire, this interactive render engine, you'll see here that in a couple of clicks, we have a very, very, very nice preview of how the render will look like eventually with this HDR map. Okay, this is a preview, as I mentioned before, and we can of course use the production render, and you will see that Maxwell is going to perform this progressive way of Maxwell is going to depict how the loop is going to be generated. As far as the time is passing by, you can set up a goal, a number of minutes, or a specific sampling level to achieve a certain amount of quality. So just in a few seconds, you can see how easy it is to deal with Diverso. Now, we're going to move on the next step, and I'm going to leave you with Luis, which is the master of RealFlow, world famous for his blog. And he will talk us a little bit about Híbrido in this case. Let me open up a scene for Luis, probably this one. Yes. All right. So go.
Okay. Thank you, Victor. It's amazing. Okay. I'm going to explain how to work with Híbrido. Victor explained and scene with working with Diverso, but Diverso is the new group of solvers working in RealFlow. You know, we have the HPH, and the HPH is the older solver we have in RealFlow. But now in this version, we have Diverso. It replaces the older HPH solver, because Diverso has a couple of solvers, three solvers, DAMP, PDB, and SPH to much faster, and it can be awesome because you can use here. I'm going to create. Wait a minute. I'm going to create a Diverso domain, and here you have the possibility to use the GPU and the CUDA, and the performance with the GPU and CUDA. It's very amazing with working with millions of particles. So it's going to be a interesting way to work with particles, because you will see a best improvement about your simulation, saving time for your production. Okay, so I'm going to explain a bit the difference between Diverso and Híbrido. So Diverso is focused on small and medium scale, so you can make scenes with millions of particles, of course, but Híbrido can handle hundreds of millions of particles. So that is the big difference. So because Híbrido is based on a flip solver, and meanwhile the Diverso is a group of solver with HPH and PVD solver. And Diverso will require more machine recurse to make the scene if you want to simulate with for example 100 million particles. So if you want to create a complex scene with particles with millions and hundreds of millions of particles, your solver will be Híbrido. Okay, I'm going to explain the scene with Híbrido. I'm going to remove the Diverso domain. So the good thing with Híbrido and Diverso, when you are making the setup in RealFlow, is you don't need to imagine or to create different ways to make the setup for both domains, because you will have the same setup for working with both solvers. Okay. For example, I'm going to start the scene again. You know, we found water in Mars, so I'm going to import the geometry. I'm going to create maybe here we can import the geometry as ESD file or a multibody. Multibody is ESD file, but it can contains a lot of nodes with as one single node in RealFlow. So I'm going to use the multibody because it's more comfortable for me. I'm going to select this one, and here we have the model. So I'm going to scale directly. I don't like to use the scale. I don't like to use the scale for geometry because you can. Many people are asking what is the correct scale to work with RealFlow. I always say that the correct scale is geometry scale 1, okay? Because if you think that your scene, your model has a lot of meters to work with it, you will need to think that the demons will need to be rescaled to work with them too. Okay, I'm going to keep this value, and I'm going to scale manually the geometry. Okay, maybe in this way, and you know that I'm going to move the geometry here. Okay. Here we have maybe a bit bigger. So you know that we have different ways to work with the scale. If you know that every grid square in RealFlow is 1 meter, I know that this model is around maybe 10, 20 meters. Okay, it's more or less. Okay, so. The first thing we need to create when working with Hybrid is the domain. The domain is here. I'm going directly creating the domain directly here in the shelf of Hybrid. And here we have a rectangle. It's weird, but it makes sense when you know what you can do with it. So using these cubes here in every corner in the Hybrid domain. So it means that the Hybrid is based on flip solver. So flip solver means that you can control the particles by using cells. Cells are these. Okay, so this one and the other one. But if for example, I'm going to reduce the scale, so third side scale is I'm going to set 0.5. You see the third side it's smaller, but every cell has 8 particles by default when you start to run a simulation with Hybrid. Okay, it means if you have small boxes, when I'm using, for example, I create the Hybrid domain, and now I'm going to create the meters. Unlike Diverso has circular meters, square meters, sphere. Hybrid is based on geometry meter. Okay, I'm going to create a couple of boxes, a couple of cubes. Maybe I'm going to duplicate this one, and now I have 2 boxes. They're gonna be 2 emitters for Hybrid. So select the first cube in the Hybrid shelf. I'm going to select the emitter. Check the cube 1. Happy is included as emitter in this Hybrid emitter. Okay, the same thing for the second cube, and the second cube is the same. Okay, now I have 2 emitters, but nothing's gonna happen because the emitters needs to be connected with hybrid in the relationship editor. Okay, so I connect. You can press Control and drag and drop the node, the emitter node to the domain, or you can click on in the image of the node and drag to the other node you want to connect. Okay, so I'm going to show the box here. Okay, I'm going to move. Okay, here we have the boxes with the cubes with a cross. The cross is indicating that this geometry is chosen as emitters. So I'm going to select one emitter. You can select here. You can select in the relationship editor. But all emitters have the same parameters. So I'm going to select this emitter as a stream, so to emit constantly, and indicate that it's constant. Constant. If you see, we have a arrow to apply a direction for the fluid. Okay. I'm going to make the same thing for the other one. Constant. Maybe the other place. Okay, the other direction. Okay, now I have the two emitters configured. If I simulate now, I'm going to remove the command line. Also, I'm going to enter in the hybrid options, and I'm going to set this one the max substeps for 1. So why is this? Because the min substeps and max substeps is very good when you're working with geometry, animated geometry moving fast, or the fluid is incredibly fast, and you will need to increase the values for the min and max substeps. Okay. So for this simulation, 1 min max 1 is enough, and you won't need more to make this simulation. So okay, so if I click on I'm going to remove also the reset to initial state, reset scene. If I simulate now, I'm going to say I spawn node and simulate. So here we have the fluid. But what happened? But like hybrid, like Diverso, we need force to affect the fluids. So in this case, we don't have gravity. So in the relationship editor, there is a trick in the RealFlow. If you press tab in any place where you want, the box to choose what to put to add to the scene will appear. So I'm going to create a gravity. Okay, I have my gravity and connect with hybrid domain. And now if I simulate the same thing, the fluid is falling down, but it won't collide with the geometry. Why that? The geometry is not connected either with the hybrid, so we need to connect the geometry. I'm going to show you as well a new method to select the objects, because it's confused for me to see this grid of vertices and polygons in the viewport. So I'm going to go to the preference, display, and here we have display outline. Okay, and now we have outlined selected geometries or emitters or what you want, or meshes. Okay, it's the same. So I'm going to connect the multibody with hybrid domain, and this is important because the fluid will collide with the geometry depending on the isosurface of this geometry. It means, okay, I'm going to show you that this geometry as bounding box. I'm going to the display tab. I'm going to show you the isosurface. So you see that the isosurface is pretty good in this case. But if I go to the multi-body cell side parameter, if I put this parameter to, for example, 0.8, you see that the isosurface is changing. So this is calculated based on the distance fields for the geometry. So you will need to make sure that the third side is the good third side to work with the fluid, because the distance fields for this geometry, the isosurface for this geometry, will be used to collide with the fluid. So if we will use this geometry with this isosurface, the geometry will collide with a very simple mesh. Okay, so I need to reduce this value. Maybe 0.3 is good. You know that the domain is 0.3 as well. Okay, so once we have the third side and the isosurface as we want, we can remove the isosurface. But I would like to explain another thing with this, because it's important. It's possible you reduce this value so much, but and the geometry is not perfectly created. The isosurface is not perfectly created. So why that? Or what can you do to fix that? So if it happens, you can't reduce the third side anymore, because if you reduce the third side more than a very low value, the memory RAM will be collapsed. So that is important. So what's the solution for that? The solution for that is, for example, I'm going to put 0.1 here, and if I put surface offset, maybe with this value, you see that the object, that the isosurface for this geometry has grown up a bit. So I'm going to 5 for example. So with the thinnest geometry, you will need to use the surface offset for sure. Okay, that is important because the third side if you use the third side with very low values, your machine will collapse for sure. So it's important for that. Okay, so I'm going to set, but for this geometry it's not necessary. For this geometry, with 0.3 is enough. Okay. Okay, it's enough. Maybe 0. Okay. Okay. So I'm going to uncheck the isosurface, and I'm going to show the geometry again, and I'm going to simulate. Maybe I'm going to place the emitters here, and I'm going to change the color of these emitters, because I don't like the yellow color for emitters. Okay, I'm going to simulate, and now we see that the fluid is colliding with the geometry. Okay. You can control also. You have parameters to control how the fluid is affecting is affected by the geometry, because if you select the geometry, you will have here a grid friction, for example, and you can place a texture here, and you can control the interaction factor. The interaction factor is a very good parameter, because if you see that your object, your geometry, which is animated, is pushing very violent the fluid, you can reduce this value to control how it is affecting the fluid, or you can increase this value to create more vortex in the fluid. Okay, I'm going to leave this parameter to 1. Okay, and once we have this the scene simulated, I'm going to write some frames for all. Okay, and I'm going to hide the meters, and I'm going to save the scene and now simulate. Also, you can simulate the scene by GUI. Okay, directly in the GUI of RealFlow, or you can also simulate the scene in the command line. Okay, simulating the scene in command line is more or less 33% faster than simulating in GUI. It is because you don't need to paint the particles in the viewport, so it's obvious. Okay, I'm going to stop the simulation here. And now, once we have the scene simulated, for example this one, I'm going to move here, and I didn't say, but in the hybrid domain we are exporting the GVC. The GVCs are the fields necessary to create the secondary for hybrid domain, but you can use also BDB. I prefer to use BDB because it's more of most of 3D package can handle BDB format. Okay, I'm going to leave BDB, and I need to simulate again. Of course you don't, but you will need to create a graph in the simulation flow to convert the GVC format to BDB, but for this simulation is fast, so it's not necessary to make the graph. Okay, here we have the simulation, 22 frames, 23. Okay, and now once we have, I'm going to 23. If I move the child line, I see the simulation. Okay, so if I want to create secondaries, splashes or foam for this simulation, the first thing we need to do is simulate the hybrido. We can simulate hybrido and splashes and foam all at the same time, but the simulation will be very slower if you simulate all together and if you simulate by separate. Okay, so it's important because I'm going to say some tricks to speed up the secondary simulation. Okay, once if you have the simulation for hybrido, the easiest thing is set to cache the hybrid domain, go to the hybrid shelf and create the splash. And the splash needs to be connected with the hybrid domain in the relationship editor. And now I'm going to set particles, the parameters for splash here, for example, this parameter to 108, and the curvature threshold maybe 2, and this parameter maybe through this one, and what else? And I'm going to increase the maybe a bit more 8 here. Okay, and I like to create the spline mean lifetime to kill the splash particles. Okay, so I'm going to set this is in seconds. If you don't know, this parameter is in seconds, so we need to set maybe 0.2, 0.2, and 0.5 for example. 5. Okay, so it means that the particles is going to be in the scene in this time. Okay, 0.2 is maybe if you multiply the frames per second by this value, the particles will be start to die in 15 frames. Okay, so another thing to keep in mind with splashes is we have a cube, and we need to place the cube where the splashes are going to be created. Okay, if only I want to splash in this area, so the box will be in this area. But for now, I want the splash for all things, for our areas. Okay. So what else? I need to create a gravity for a splash too, but or I can connect the gravity I have in the relationship editor for hybrid domain as well. So we can connect this. But if you take a look at the relationship editor, there are many nodes. Not now, but there will be many nodes in the scene. So it's useful to work with hubs. I'm going to create a hub. I'm going to remove this one and connect the emitters with the hub and the splash too. I'm going to connect the splash with this hub too, and I'm going to create another hub, for example, to connect the demon. Maybe I need to place another demon, and I need to connect with this hub. So now I need to connect the hybrid with both. Okay. Now I know that the hybrid domain is affecting this node, and this node here is affected by these nodes because hybrid is connected with hub 1 and hub 2. Okay, and also with the geometry, but the geometry is connected directly with the hybrid domain. Okay, that's the hub are very useful. Unfortunately, you can't connect hubs between them. So maybe for next version. Okay, so I'm going to simulate. I'm going to save the scene. Okay, and here we have a few splashes, very few splashes. I'm going to hide it. We can increase the number of splashes here. So splash, maybe I'm going to put one here, and maybe here in emission rate. Yeah, here we have more splashes in the scene. Okay. One thing I like to do with the splashes is to kill them, when they are colliding with the geometry. So I'm going to place a collision, and connect the collision with the splash and select the multi-body because it's my terrain. So you will see that but it depends on you what you need. But it's sometimes it's good to have this one because you know that the particles, the splash particles, are small particles, and if you see a particle colliding with a rock and bouncing in the rock and go to the sea again, I think this is complicated to see that kind of behavior in the sea. Okay. Okay. Here we have the scene with the splash, and once we have created the splash, the same thing for foam. So I'm going to the foam. I'm going to create a foam. I'm going to connect the foam with the hub. Okay, and the splash is cached. I don't need to create another splash simulation. So I need to set this splash to cache to avoid simulate the splash again. Okay, here, and this is important. With you create a foam, it's not necessary to connect the foam with gravity, because the foam is will be on the surface of the hybrid. Okay, if you connect the foam with a force, you will be forcing the particles to do something that they can't. So it's only connect the foam with the hybrid with hybrid. Okay, and the same thing with for the hybrid foam. Okay, configure the parameters. I'm going to create the foam from splash. I'm going to create from splash and from domain. From bubbles is not necessary. But there is a trick. When we are using the foam or based on foam meters, it's foam, hybrid foam, bubbles and foam, waterline. Okay, we can set the liquid particle solver mass substeps in the hybrid tab to 1. Okay, if you set the mean substeps and mass substep to 1 and 1, you will be speeding up the simulation a lot. Okay, I'm going to create that. It's not the same for a splash. The splash needs if you set the mean substeps 1, the mean and max substep 1, the splash probably will explode in simulation. So, but the hybrid foam, like as the particles are going to be on this hybrid surface, it won't need to have more mean substep or mass substeps to control how the particles behave. Okay. What else? I'm going to simulate this one. Okay. Maybe. Yeah. Here we have one too. I'm going to hide the plus, and this is the one. Okay. This is the fun. But I would like to show you also. It's necessary to create a K-volume demon in the scene, because maybe we don't know, but the particles are colliding or introducing in parts of the geometry where the particles can explode. So it's useful to create a K-volume to control that the particles can travel very fast in the scene. If not, the run will be increased, calculating the particles if it is very far in the scene. Okay. So I'm going to connect the car volume with this hub here, this demon hub. I'm going to rename with demon hub. Demons. Okay, and in this case, hybrid emitters, for example. Okay, what else? Also, we can control the particles by using a geometry, and we need to have clear a couple of concepts when we are working with geometries and diverso and hybrido. It is the volume outside or volume inside. Okay. If I put this box here and I want that the particles are inside in this box, I need to control. I need to say that this box is gonna be a volume outside. Why? Because the particles are going to be inside. Okay, I don't want particles outside of the box. So in this box, we need to select solid outside. Okay. If not, if you try to do the proof with volume inside, you will see that the particles will be exploited because you are putting particles in a wall, for example. Okay. So I'm going to scale down a bit. Okay. And the geometry, always geometry. If you want to collide the fluid with the geometry must be volume mode solid inside. Okay, we have a shell mode here, but it is useful when you have a geometry with where the thickness is you don't have a double phase. Okay, so imagine for example a plane here. I'm going to create a plane, and you don't have 3 dimensions here. It's all, well, so you have shell. If I display the surface, you have here the surface. If I display solid inside, okay, the plane is not. Sorry, here. You see strange things with the plane. So the correct thing for this kind of objects is to work with shell mode. Okay. So I'm going to load the final scene, and here we have. In this case, I don't have the splashes or foam, but I have only the mesh. I'm going to hide the mesh in this case, but also the fluid. Okay, here, and we can use the hybrido with the hybrido BDB mesher to make the mesh with hybrido solvers. Okay, if I select the hybrido mesh BDB node, here we have all parameters to be configured for this mesh. Okay, I'm going to show the mesh, and I'm going to hide the particles and don't read the particles at all. And here we have the mesh. Okay. We can, of course, it is based on the mesh is based on BDB, so we can control the volume filters. It's very useful to work with. For example, I'm going to create. I'm going to check the road. I'm going to make sorry, we don't have the particles. I need the particles available to work with the mesh. So, okay, I'm going to. It's the mesh is going to be created, and now it's applying here we have the mesh. If you see this mesh, it is because also I calculate the displacement maps for this hybrid domain. Here you will see here calculate displacement always, and here we have the parameters to control how the displacement is applied in the mesh. Okay, and also we need to check the displacement texture here in the Sport Central. Okay, I'm going to remove the particles again, and in the mesh I was saying that the use displacement is checked as yes to use. Okay. Okay. The good thing with RealFlow now, it's we can render the mesh, the result, the particles you have directly in Maxwell render from here, and you don't need to go to other platforms if you want to make a quick preview of your scene with a professional render. Okay. So I'm going to select the render tab, and I'm going to check the file. Here we have a waiting box resizing. Okay, depending on the mesh you have in the scene, the render will be shown in the file. So in file, I'm going to remove. I'm going to the Maxwell settings. I'm going to remove the use the HDR image. I'm going to use the physical sky, and okay, and I'm going to render again. Maybe I'm going to select the Maxwell. All nodes in RealFlow has a Maxwell tab to control what is the material you are going to apply. Also, we have the UV channel, and I can paint the velocity channels directly in the viewport or in the render in this case. Okay, and for this example, I'm going to set this to default, and I'm going to render again. I'm going to check the alpha channel and render. Okay, and here we have the mesh. Here we have the mesh. Okay, and maybe I'm going to check one thing with the geometry to know what is not appearing in the render. Here, display, and from file, okay. I'm going to choose from node. You will see a beautiful yellow color in the geometry. So render again. Here, in few seconds, we have the render here. Okay. Keep in mind that this is not a very fast machine. Okay, but you see that the fluid is appearing here, and the geometry is finding. It's rendering with the fluid. I'm going to stop the simulation. the render, and you can modify the ISO surface, the ISO for the render, okay, to see better the result. Okay, and that is all. It's a pleasure for Victor and me to show you how RealFlow is working, and let me show you several videos. Several videos. Where is the video? Where is it? Sorry, I'm asking Victor to
right.
where is the videos?
Here we are. Webinar.
Okay, here. So you can check this simulation with Diverso. Okay, I don't know if you can see the video properly, but I can show you the frames. Okay, and the same when we are using the Hybrido. Here we have a scene where there is a helicopter hitting the submarine, and a lot of particles, the secondary particles, okay, and the submarine is exploding. And also we have another scene, another render with another simulation with Diverso. Here with you can control one thing I didn't say is that you can control now the demons with follows. You can see the yellow boxes. It means follows for demons. It's important because I like very much the follow for demons to control the forces and how it's affecting the fluids. Okay. What else? Maybe this one. I remember somebody asked me for a simulation with a big monster in the sea. Okay. I need to. Sorry if you can't see the video very fluid, but it's okay. It's pretty cool. Okay. And this video, maybe you have seen this video before, but it's all. This video is all made inside the RealFlow, the simulation and the render. Okay. This is the video of the Swir video. Okay, and this video is only with Vortex. I'm going to prepare a tutorial with this video. I'm preparing a tutorial with the video, but basically it's a fluid with a vortex and bubbles and so on. Okay, and also there is a ocean fulfill, but you will see. Okay, and that's all. If you want to I don't know what to show you more. Maybe this one a scene made with Hybrido and rendered with the Maxwell render from Victor. It's totally using viscosity with Hybrido, and Diverso has also, of course, viscosity too, but in this case is Hybrido. Okay, and Diverso BDB for me is we have the possibility to be rendered with Maxwell render inside the RealFlow too. Okay, and that's all. This one Victor is pointing out to a couple of more videos. Okay, so this one is pretty awesome because it's used with a test chart. The fluid is creating a test chart, okay, and the same for this video. Here we have another simulation, another amazing simulation with iVido. Okay, thank you all. Thank you for coming. Thank you for watching. Thank you for hearing. Thank you for...
Yeah, thank you for your time. Basically, it was a good pleasure, and definitely we will do our best in order to, generate more examples. We have millions of questions here and answered questions here, and we'll try to collect them all and forward you guys. There's a lot of people asking us about much more advanced stuff, actually, and we have very nice ideas from many of you guys, and we'll definitely try to bring back more cool stuff and more advanced tips. Most of all, primarily you're asking about, speed up workflows, more efficiency, more precision, basically about saving time, which is pretty reasonable, obviously. And we'll definitely try to do our best in order to bring back more cool stuff. Once again, thank you very much. And see you all very, very soon. Once again, thank you for being there. Thanks.
Thank you very much.